Okay.
Good evening, Dr. Rajadas. This is Harrison Chanot from the Disulfiram for Lyme Facebook support group, and we are really glad to have you here as a guest. This is Dr. Jayakumar Rajadas, who, along with his brilliant team of scientists, discovered disulfiram's efficacy for Lyme against Lyme in 2015, and
2016.
2016. He
Yeah.
is the director and team leader of the Biomaterials and Advanced Drug Delivery Laboratory at the Stanford University School of Medicine. I wanted to give him a very warm welcome on behalf of all Lyme patients and the Disulfiram for Lyme Facebook support groups. I really want to thank you for taking time to speak to us, and thank you so much for all the work that you've done to try to help improve the quality of all Lyme sufferers' lives. To start out with, I was hoping you could just give us a little bit of your background quickly. I know you're from India, and then we'll go into how you started in Lyme research in the recent few years.
Yeah, thank you very much. And also thanks to all the Facebook group friends and organizers. Thank you very much. Yeah, I mean, as I mentioned to you earlier, Harrison, I am originally from India, a place called Madras, Chennai. This place, it's a kind of south of India, um, where I got my doctorate education also from a place called Indian Institute of Technology. This institute is world-renowned institute where a lot of very notable people they got their degree, and including many of the software engineers. They are all from that place. So I got my PhD degree and I become a faculty there. And I spent about 15 years, 15 to 16 years. And then during that time, I developed a therapy, for regenerative therapy for wound healing, and also developed a therapy for heart diseases. And at later part of my stay in Chennai, I was more interested in developing therapy for neuroinflammation. Neuroinflammation that leads to similar condition like multiple sclerosis. Because I'm from India, I wanted to study something that is infection triggered neuroinflammation. So, our hypothesis is when people are undergoing some chronic infection, they develop neuroinflammation. And then the neuroinflammation is kind of perpetual inflammation. That's why we think, like people have a lot of pain and a lot of other kind of problems during the ongoing infection, even after they resolve the infection, even after the bacteria or virus, whatever the fungus, whatever that affects, that cause this neuroinflammation, even after they are gone, there is so much imprinting of pathological proteins and also the bacterial products in the brain that lead to, complete, continuation of perpetual inflammation. So this was kind of my area of research, and a few of my graduate students, they were doing their doctoral research in this area, and then we found out this neuroinflammation increases some of the amyloid protein in the brain, including A beta amyloid, the protein similar to Alzheimer, causing the Alzheimer disease. So we hypothesize, like, because of the acute exposure of inflammation or any other inflammatory agent, brain develop a chronic inflammation, and because of the chronic inflammation, people, they have excessive amyloid proteins in the brain, and that amyloid protein causes toxicity, and because of this toxicity, people have a lot of cognition problem, and the pain-related symptoms they have. So this is what our hypothesis is. And interestingly, when of course in India, in my lab, unlike my lab at Stanford, we can't do infectious agents that easily because we didn't have that BSL-2 facility in India. So what we did is we try to take amyloid protein or protein that can cause a neuroinflammation, like casein injection and all. It's a milk protein. We used to inject to these animals and then induce neuroinflammation in their brain. We also use silver nitrate, and then we inject the silver nitrate to these animals, and these animals develop a neuroinflammation. And then we study them. So during our study, we also, my focus is always the therapy. We just develop an animal model and then try to check what are the causes for causative agents for the pathological condition, inflammation in their brain. And then we try to develop a therapeutic molecule. And we found out a therapeutic molecule. We developed alpha-B crystallin. It's one of the heat shock protein as a therapeutic molecule to reduce the neuroinflammation. And it worked dramatically well, actually, our therapy. How we found out this molecule, that's, if you guys have time, I can elaborate it. Stop me when you think it is not very relevant for the discussion.
Yeah, I didn't want to spend too much time on your irrelevant work to Lyme disease, but it sounds like that's somewhat relevant in that it was related to neuroinflammation.
Yes. So the idea is this particular protein is plenty in our islands, actually, mammalian islands. And the islands is a very interesting, basically, an organ, because when the very high density photons, there are a lot of free radical traffic there. In spite of that, it is not getting damaged. So we thought probably some protein there, it's a very good antioxidant, and also it can handle whatever the high free radical traffic very effectively. So we figured it out. Alpha-B crystalline protein that is there in the islands, this is also a heat shock protein. So we thought this protein will be a very good therapeutic agent to reduce the brain inflammation. As I mentioned, it's basically an islands protein, but we have very little expression in the brain. So what we did, we took these animals and then we induced neuroinflammation on them, and then we injected this protein, recombinant. The protein we used both recombinant and also we sourced in the cow eye lenses, and then we extracted this protein. We injected. We saw a dramatic effect. All the inflammation disappeared, similar to what we see in disulfiram. Very interesting data. Then we wanted to publish a very good journal from India. Unfortunately, we couldn't publish because it's very difficult to publish it in a good journal from India. So we published it in OK journals, like about 4 papers we published. Anybody's interested, I can send the papers to people. And we showed very clearly that by injecting this protein, you can reduce the neuroinflammation. Later, my work, it was noted by another scientist. Same thing happened here also. And Dr. Kim Louis saw our work, and then he repeated it. There was there's another scientist actually in Stanford. He didn't know I'm just visiting Stanford at that time. He just independently developed knockout mice, and then he wanted to check, after reading my paper, he wanted to check whether the heat shock protein alpha-B crystalline will have a therapeutic effect to reduce the neuroinflammation. To his surprise, he saw very good effect even in his knockout mice model. And then we were so excited, and that paper went to a very big journal. It's Nature, a big journal, a very reputed journal. And in fact, he also quoted as that it was originally we discovered this effect. And later this work is also went to human as it is in the disulfiram, and they saw a very good therapeutic effect in Netherlands. I can send all the detailed papers if people are interested to see how this particular therapeutic protein worked well. This is my first discovery in the area of agents to reduce neuroinflammation.
Did
This is about our work in India. And 2007, I totally moved my lab from India to Stanford University. After that, after coming to Stanford University, in fact, I was hired by neurology department. So my area is here to develop therapeutic agents for Alzheimer disease and also neuroinflammation. And then when people saw that I also have a lot of experience in biomaterials and drug delivery, so they started collaborating with me. So a lot of products came. As I mentioned to you, I have about 72 patents, and about 29 of them, 29, 30 of them is in the process of commercial development. So this is what happened from 2007 to 2019. This includes disulfiram also, and also another molecule, azlocillin. If you have any specific question about whatever I told, then I can move on. How disulfiram discovery happened.
Yeah, just to wrap up that whole thing, all that research you did on the anti-inflammatory protein in India for the brain, did that materialize into a drug, or is that just scientific research?
So that's a beautiful question. It's very difficult to develop anything as a therapeutic agent at that time from India. So I didn't apply for a patent for that particular product. So I just published it because we were quite excited. But Stanford, I realized later, of course, without me, the Professor Lawrence Steinman, he filed a patent. He got a patent. He started a company, and later another collaborator of Larry Steinman, he started a company when he saw such a dramatic effect of this protein in the brain. And then he started a company, and then he raised money. He completed the clinical trial. He published that work few years ago. And I really don't know what level it is. I don't know whether it went to people or not, because I didn't find funding here to continue this alpha crystalline work we originally discovered in India. This is one of the story, like if you don't have continuous funding, even though you are the original discoverer, it is very difficult for you to take it to the clinic. And the reason for that, if the idea is very good, somebody else will come in between, and they will try to raise a lot of money, but they may not have the similar passion of the original discoverer, is having. So because of that, generally somebody discover that and somebody develops it, the person developing, they may not have that much passion of the original discoverer. This is very pathetic situation. This keeps on happening in science.
Yeah, I mean, we're hoping to, in part, help to give your team the full credit in the history books for the discovery.
Thank you. Thank you very much. Thank you. More than credit, I really want some, possibility of resources for us to continue. We continued the disulfiram research. We never stopped, actually. Maybe you are aware, we published another paper in very recently, not published. We put our preprint, and this is still in consideration for publication.
Yeah, it's my understanding that you guys have worked through an absolute drought of funding, and we should all be very grateful that you guys have even survived this and are continuing to help do
Yes.
amazing research.
Yeah. So we have a lot of exciting data, and we are likely to send few more papers in a month. Lot of exciting data. Disulfiram, very amazing molecule. In fact, we showed it at least in animal when we triggered inflammation in them through Borrelia infection, even acute infection. It need not be a very long infection for them. Even an acute infection, we showed a lot of pathological changes in the brain, and some of them is kind of if you leave it untreated, it can stay for very long time. We showed that. And what is interesting is when you treat them with disulfiram, we saw all the pathological processes reversing. That is something amazing. We never saw anything similar to that. Of course, we saw a similar curative effect in alpha B crystalline, and this is the second molecule. We saw a very good agent that can reduce the neuroinflammation. At the same time, maybe you are aware that we developed a slow delivery formulation that it appears it is clearing the Borrelia very effectively in animal model.
I wanted to ask more questions about that a little bit later, but
Okay.
just because you touched on it now, why do you think the disulfiram is lowering brain inflammation? Is it just because it's eliminating the bacteria, which is the source of the inflammation, or is there some other mechanism? And what would that be?
Yeah, that's a wonderful question. In the number one, disulfiram, it's such a uh, very interesting molecule. Generally, we never see anything similar to that. You have an antibacterial effect. At the same time, it is also having an anti-inflammatory effect. You never see this kind of same thing in two-in-one kind of molecule. Disulfiram is like that. In this particular model or that particular disease, it is eliminating persisting bacteria. I mean, other people also showed. We have very effectively showed that. That's one thing. The second thing is specifically when a Borrelia infection happens, we showed that a lot of pathological proteins are upregulated, and that particular molecular mechanism, disulfiram, is halting that of upregulation of these pathological proteins. So we call it as a perpetual inflammation. When some kind of inflammation trigger, either it can be due to virus or a fungus, or in this particular case, a Borrelia infection, or the product or the derived products of the infection. When it gets into the brain, that trigger a perpetual inflammation. And interestingly, disulfiram is halting the perpetual inflammation. So the answer is yes, it is both. It appears it is clearing the infection, what we call it as a sterilizing the mice. And at the same time, it is also reversing some of the inflammatory pathway triggered by the original infection.
Wow. So it's halting an inflammatory pathology or a protein or some protein that's pathological basically, and it's stopping
That's
that.
correct. That's correct. Yes.
Interesting. So just to take a step back a little bit, how did you personally get started in Lyme research?
So it is 2011 when Stanford University, in the School of Medicine, we started getting a lot of patient population, especially with the chronic symptoms. They started complaining when our clinician started, when we're treating them, they started complaining there is no proper treatment is possible, available at that time. So because as you know, many people are not convinced the Lyme disease is likely to be a chronic problem. So that because of that, but at that time our School of Medicine, they formed a small they assembled a group of scientists from Stanford. They call it as a Lyme working group. And then they asked us to focus on specific area. I was asked to be part of that group because of my drug development interest and also my interest in neuroinflammation. So because, maybe you are aware, people think all the symptoms because the immune dysfunction and also neuroinflammation. So because of my experience in these two areas, and as a drug developer, so I was part of it. And then I was very fortunate at that time to meet the founder of Bay Area Lyme Foundation, Bonnie Crater, and also Laurie Woods, and both of them supported me like for about 4 years. And they gave a lot of funding to me and asked me to start the drug screening, and also helped me to get all the Borrelia strain, to recruit the team. Phenomenal support for 4 years they gave. And with that help only we published the first paper on the effect of manganese transporting porter inhibitor loratadine on possibility of developing it as a anti-borrelial compound. That is the first one we did. And the second molecule, the second paper came in 2016 paper with Dr. Ravindra Pothinin as the first author. We published the top 20 molecules which we thought that one of them or two of them will really solve the Lyme problem. So that is how it's all started. It all started because of the support of Stanford University and also support of Bay Area Lyme Foundation at that time, the initial 4 years.
Interesting. So on the timeline, you actually found disulfiram in 2016, not 2015, because I have it on the.
No, actually, sorry. You are right. We found out we completed the work by 2015 itself, but we published, our paper came out 2016. You are right, 2015.
Okay, interesting. So could you tell us a little bit about the recent studies that you've done in mice, or basically the general history of the studies that you've done in mice and what you found?
So what we found, actually that paper is already there in BioArchive. Anybody interested, they can see. So the bottom line is this. When disulfiram is a very fragile molecule. It's not, in a body, it's not very stable molecule. It leads to it degrades into lot of metabolites, where mainly liver actually. Other places also it is getting metabolized. And in our lab we are very carefully looking at the profile of the degradation profile of disulfiram, even in vitro. My lab, they are continuously studying. And if you put it in water or with a different pH, depending upon the pH, the disulfiram automatically degrades into a smaller unit. So it's not a very stable molecule when people take it by stomach. Especially in an acidic media, it tend to degrade very fast by itself, Then it gets into the liver. When it gets into the liver also degrades. Liver, as you know, it generally degrades a lot of whatever the therapeutic molecule we are applying to there. It's called first pass metabolism. That's the job of liver, because anything we take, liver is kind of degrading it. Sometimes it is adding some soluble agent like sulfates, phosphates and all. So all these things happens. So liver is kind of a big factory. It processes whatever we take orally. And also whatever later we are injecting to the blood, that is also getting into the liver. But oral one, it goes to the first pass. The first thing it meets the liver, and after liver clears it, then it is available for other kind of blood circulation. This is how it happens. So what we figured it out, like the borrelial killing activity of disulfiram is basically the prodrug. It is not, I mean, so far, whatever we found out in test tube, it appears the intact disulfiram molecule is needed for the killing of Borrelia. So so that means if we can delay the liver absorption, the blood absorption, because if it is kind of effervescent way, like, the absorption happens in the upper part of the gut, then all of them are likely to go to liver. When it gets into the liver, all of them, most of them in fact, get chewed up, and then you don't get any therapeutic efficacy at all, at least for killing the Borrelia. But if we can prevent it, push the absorption to the lower part of the gut, then we can reduce the amount of the drug exposure to the liver. So then we can also control amount of metabolism, and we can improve the borrelial clearance. That's what we showed when you were giving an IP injection. We showed we can clear the Borrelia, not very, very complete clearance we saw, but we are very interesting maximum amount of Borrelia that is totally cleared by this method, by just giving an IP injection, intraperitoneal injection. So, and also, as I mentioned, and you also mentioned, that we developed a oral formulation, and that oral formulation is likely to clear the Borrelia as effectively and sometimes more effectively when compared to the IP injection.
So the studies in mice, though, how many have you done roughly? How long were they? When did you start them? How many years of studies have you got? How many of them are there?
Basically, we found out the therapeutic effect of Borrelia by this our 2016 paper, and then for the past 3 years we have been continuously developing formulations and developing method of delivery and trying to find out the way to delay the bioabsorption of the drug disulfiram in the animal model. So we have been doing, we completed our efficacy study by early this year, actually, not early this year, mid last year, 2018, middle of last year, we started having good data, like around September and all, we started looking at it very carefully. This is because Dr. Kenneth Lehner keep motivating us that we are likely to get a very good therapeutic understanding if you continue this study. So he used to call me almost weekly once, and then encouraging us, motivating us to continue the study. That is how we started working very, very carefully. And by early this year, we completed that study also. So we started writing papers, and then we started submitting these papers. And currently, we are for the past 8 months, we are working on the neurological effect, how the biological signaling is changing. Those kind of questions we are asking by borrelial infection. In fact, in 2018, early 2018, we published a Journal of Neuroscience paper. We just took the fragment of outer coat protein, a triacylated peptide. We injected this peptide to this animal brain and then showed how this particular, even it's a small fragment, insignificant fragment, still it is causing a lot of inflammation in the brain, upregulation of a lot of pathological proteins, and you can measure the signaling. the brain signaling changes drastically. That explains, how the spirochetal outer coat proteins are toxic to the brain. So we showed when we published, in fact, that particular paper got into a cover page of Journal of Neuroscience because people liked in the way we explained the mechanism of neuroinflammation caused by some of the degrading protein fragments. We call it as the lipopeptides.
Well, I think some of the viewers might not know about just the general efficacy studies of disulfiram against Borrelia in mice. How many have you done that have shown Borrelia actually fully eradicated, or sorry, disulfiram fully eradicated Borrelia in mice? How many studies have you done that have shown that?
We actually we repeated this about so far 3 times, and 3 times, with the formulation that we think it works in orally. We also have a lot of negative studies. Like, for example, we formulate in a typical other people, generally they use some grass ingredient. When we use those ingredients, general ingredients, we saw all of them get into the liver, and then they have a lot of liver metabolites upregulated in this, and then we never got any kind of good sterilization in this formulation. We found out a specific formulation that when you delay the formulation to the lower gut absorption, then we found a very good therapeutic efficacy. So it's kind of a very, very intense formulation work. Basically, you check so many ways, and then you try to understand how to deliver it. So it's a typical drug delivery problem. I think we resolved this at this point.
So just to summarize for the people that don't really understand, you've shown that disulfiram clearly eradicates Borrelia with intraperitoneal injection, which is basically an injection into the like stomach area, right?
No, not stomach area. These animals, they have a peritoneal cavity. We don't have a similar arrangement in our body, so we inject in that cavity, and that and then the formulation get absorbed, and it is then it gets into the blood circulation. This is not like delivering the formulation in the lower gut. It is in between, in between you're taking it your oral and also delivering into your lower gut. So you don't get like 100% efficacious removal of Borrelia by this method, but we can see a very significant maximum amount of Borrelia removal in this particular method with an IP injection. We do believe, with an appropriate formulation and then delivery directed to the lower gut, we can achieve 100% sterilization.
But just to be clear, did the studies using IP injection in mice show that you could eradicate Borrelia or no?
Yes, we can eradicate Borrelia, yes.
So so you're saying that the absorption in the lower gut is actually better than IP injection?
That's correct.
Okay, but taking it orally, the way that people take disulfiram presently is inferior to IP injection and lower gut.
That is correct. That's correct. But following Dr. Kenneth Lehner protocol and Dan Legner protocol, people are kind of taking into a smaller portion and trying to delay the delivery as much as possible. I think they are getting there. So whatever the therapeutic efficacy you see, it appears that by a different method of taking this therapeutic dose, people are trying to learn how to deliver it to themselves. And most importantly, the mouse metabolism of a therapeutic molecule is slightly different from human metabolism. Maybe we don't metabolize that fast. We are just started, we are trying to get a funding for human studies. We just waiting for the grant proposal results very soon. If we get it, we will try to study in different formulation how human they can maintain the drug level. Not infected people, normal people, how in a different formulation, how a different site of delivery can have a better disulfiram level. We don't know yet. We do have a lot of human studies with the disulfiram, but when these studies happened, at that time they were focusing more on drug, not the pro-drug. We are focusing more on pro-drug. Let me explain what is pro-drug drug in the case of disulfiram. So some of the therapeutic molecules, people wanted to have a drug, but they will modify the drug in a way when it get into the liver cleaves them off and make the drug available. So it's kind of package. They give it to people, and then liver is processing the package and cutting it, the molecule into two, sometimes several fragments. One of them is the real drug. So disulfiram originally, when it was developed for an anti-abuse purpose against alcoholics, so this was when they developed it, they found out where the liver takes it and cleaves it, and one of the metabolites is inhibiting the aldehyde dehydrogenases, the enzyme that is responsible for all the detoxifying acetaldehyde generated in our body. But in our case, it's slightly different because we want the prodrug to be intact to, and then effectively kill the Borrelia. So that is what, the challenge happens, because how to maintain the prodrug concentration for a longer period of time so that, you can get a better efficacious clearance of Borrelia in the body of animals.
So what molecule is the prodrug molecule?
So prodrug molecule is disulfiram. Disulfiram is a prodrug. The cleaved one, other metabolites are the real drugs.
Okay.
Not for Borrelia sterilization, for the other purpose, that is for an anti-abuse purpose.
So for Borrelia sterilization purposes, and we'll go into this in more detail later, is disulfiram the main Borreliacidal agent? Is it the only Borreliacidal agent that matters, or is there other important molecules?
So this is a very interesting question actually. So far, whatever the data we have so far, we think disulfiram, the intact disulfiram is the main molecule, Borreliacidal molecule. But we don't know, we are also simultaneously trying a lot of metabolites. Dr. Ravindra Pothineni and Dr. Harihara Potula, they are studying that. We don't know which, maybe some of the metabolites is also having Borreliacidal property. We don't know, because Borrelia cleaves into a lot of molecules, and then many of them, they complex with the different ions, some of them complex with copper, some of them complex with zinc. We don't know which one will be having a Borreliacidal activity. It's a long study, and we are studying that. We are basically encouraged by the anecdotal evidence by a lot of people. It appears they are becoming better. So it is worth, we can put a lot of resources and efforts to check what kind of molecule, what type of molecules are responsible for Borrelia clearance. So far, we have data to show intact disulfiram is very much needed for sterilization of Borrelia.
Right, and that should be in part due to the fact that the original study was using disulfiram in a petri dish, right? There was no animal to metabolize it, right?
Yeah, in 2000, yeah, you are right. In 2016 paper, and later the repeat work by one of the famous scientists in our area. It's all in a dish only. But currently, the paper we published, it's on animals. So we showed by giving in a intraperitoneal injection, we can clear the Borrelia. Yes.
What do you think is the main mechanism of action of disulfiram?
So we are yet to do a lot of experiments, but we have some preliminary data to show intact disulfiram is having very good binding to very important proteins in the outer coat area, and these proteins, they bind very avidly the disulfiram, and we don't know what happens next, how exactly the bound disulfiram transported to the Borrelia, and what happens inside the Borrelia to disulfiram. We don't know yet. In fact, we are continuously working on it, try to find out the mechanism.
Sorry, that was a little bit confusing to me. So there's something about binding of a protein that causes.
Yeah, so Borrelia, the way it is arranged, there is a coat. It's called outer coat proteins. So we targeted, we did a biophysical studies, and then we wanted to find out which one is having more affinity to disulfiram. It's kind of screen we did. And we identified about 3 proteins. They have a very good affinity for Borrelia. So that means you take those proteins, you interact with the disulfiram, you can show disulfiram binds those proteins very effectively. So this is like a dye. Like for some particular dye, they have a very good binding to the protein. You can take the protein and then treat the dye, and then you see irreversibly, you see the dye is binding to the protein. Similar to that, disulfiram, when you treat this disulfiram, these protein seemingly bind with the disulfiram. We don't know the binding is covalent or not. We are studying that. We are doing a lot of, we are initiating studies on that. But for sure, we know Borrelia definitely is having some very good binding partners in the outer coat proteins. When it get into that outer coat proteins, we don't know what exactly happens to those molecules. Perhaps it just getting transported inside the cytosol by binding with these proteins, and in the cytosol it is either getting degraded, or intact form it binds with some other important cytosolic protein, thereby arresting all the borrelial metabolic process leading to its death. We don't know yet. We have a lot of gaps we need to fill, and currently we are studying it, because we are also very eager to know how Borrelia is sterilizing so how disulfiram is sterilizing the Borrelia.
So it sounds like what you're saying is there's a protein on Borrelia that we know definitely binds to disulfiram, which then allows it to potentially be transported inside of the cytosol of the bacteria. Is that what you said?
That's correct. That's correct.
And then once it's inside the cytosol, which is the interior cellular world of the spirochete, then it can potentially have other bad metabolic effects, meaning it could potentially shut down certain processes that are essential for the Borrelia to
That's
survive.
correct. That's correct. Yes.
So we still don't know exactly, once it's in the Borrelia, how is it stopping it from living? We don't know.
We don't know, but we are likely to know very soon. Maybe early next year.
Interesting. What is the? I'm just curious. I mean, this would probably give you some ideas of what might be killing it. How quickly, once it makes it into the cytosol, does it end up killing Borrelia? Is it within a matter of days or hours or minutes? I have no idea.
No, definitely it is hours. Borrelia is basically, the killing rate is kind of not like instantaneous. It few hours. So obviously it's, you need few hours for them to get killed. The reason for that, they have a very slow metabolism.
Okay, just so you know, your camera's it's cutting off half your face. Maybe you could move over. Okay, there you go.
Sorry, yeah.
Do you know if if disulfiram is able to penetrate the biofilms that Lyme is often residing in?
We don't know that because that is not our area of expertise. We are collaborating with some other groups. We don't know that. The answer is we don't know.
So one of the things that I get worried about, there are a lot of people that are taking lower doses of disulfiram because they can't handle the very high doses. And if they do stay on these lower doses for months or years, is it possible that Borrelia could build up a resistance to disulfiram? Is that something you would be worried about?
No, no. Borrelia is not an organism that develops kind of mutants. Only they develop persistence. They don't develop a mutation. So I don't think I'll be worrying about it. But we don't know exactly the mechanism how people they develop very good symptom-free life after the slow delivery of Borrelia they are taking. It's a very fascinating phenomena, need to be studied, and we are studying it actually.
You said slow delivery of Borrelia. You meant disulfiram, right?
Oh yeah, I'm sorry. Yeah,
Okay.
it's a disulfiram, yes.
And as far as Babesia, we're not really sure. Would that be likely to potentially form a resistance to disulfiram?
No, no, no. I don't think so. But it's worth studying what happens to the Bartonella, what happens to the Borrelia in the animal body when we are infusing um, disulfiram at different concentration. It will be very interesting, like how uh, different organisms respond to a different concentration of disulfiram. Hello?
Yeah, I was just looking at some of the other questions here. Does disulfiram require first pass metabolism by the liver, or does it not is that a bad thing for disulfiram to be
I
effective?
mean, for our study, it is a bad thing. We think like that. It should not, we have to avoid it getting into the liver as much as it can.
Okay.
We can totally avoid because, the blood, let us say if we still having an absorption in the lower gut, still it is likely to get circulated in the blood and then later go to the liver at one point. We can't avoid, but we need not, I mean, it should not go to the first pass.
So has there been any studies in mice where it was done through IP injection? First of all, does IP injection, intraperitoneal injection, bypass first pass metabolism entirely?
Um, I mean, as I mentioned, at one point, all the molecules need to go to the liver. It can't, but definitely, IP injection is, we can avoid to greater extent the first pass metabolism.
So does the absorbing it in the large intestine, is that even more avoidance of the first pass metabolism than IP injection?
That's correct, yes.
Okay, but even the studies of IP injection have shown a complete eradication of Borrelia.
I can't tell it is a perfect eradication, a very, very significant eradication of Borrelia, but minimum amount of Borrelia is still left in these animals. But, but that low amount of Borrelia, it's likely to be cleared by our body, even if it is there.
Oh, really? And so those were not
Yeah.
the persister form. Those were the regular form that were remaining.
Um, so that's a very interesting question, actually. We do, so whatever the animal model we studied so far, we just completed an accelerated persistent model. We'll be getting the results anytime soon. But so far, the paper we published, it is kind of, you can't call it as a persistent bacterial model. It is kind of, little longer period to be called as an acute model. But this model, we saw uh, majority of the very minimum amount of Borrelia is left in these animals. And I don't think those Borrelia is kind of, we can qualify it as a persistent, because persistent bacteria develop after, we think like after like a month or something, when you leave the Borrelial population in the body. But in this case, we never leave the Borrelial population to survive in such a long time. So the answer for this, we just finished the experiments of accelerated chronically infected model. We will know the answer in a week whether disulfiram effectively clears the Borrelia in this model. But the animal experiment we finished so far, we can't say that it is a persistent model. We can say it is kind of, longer infected model. That's all we can tell.
But you have had complete eradication in some of the animal studies, right?
Yes, that's correct. That's correct.
Okay. So you're not 100% sure, but you're pretty confident that the metabolites are not an essential part of the process to killing Borrelia, right?
That's correct. That's correct.
And do you know if there are any metabolites that have any significance of any kind, or you're not sure?
We are not sure because more than about 5 to 6 metabolites, major metabolites are there. We need to procure all those metabolites, and then we need to the in vitro and in vivo work on it. It's a lot of work and very expensive studies. We hope at one point we will get funding for it.
One of the community members asked a question. He basically said that a stabilized compound was the one that was able to eradicate Borrelia, and not a regular disulfiram compound. Is that true?
Yeah, so the technology we are trying to develop is we are stabilizing, before absorbing it, we are stabilizing the disulfiram in a matrix. But again, it's just an hypothetical level. This is our conceptual level. We need to do a lot of experiment to show because of this kind of stabilized delivery, we got a better clearance of Borrelia. But we need to do a lot of experiments to show that, because if then in that case, if we develop something else, some other polymer, some other isomer, we stabilize it, and then that one leads to a different kind of Borrelial clearance, then we need to show in a very detailed way how a polymeric encapsulation play a very crucial role in the delivery of disulfiram. Again, as I mentioned, we need to do a lot of experiments to prove that is the case, and it's a fascinating science to pursue.
Do you have any idea if copper is necessary to killing Borrelia or babesia?
So we did a preliminary work with copper and without copper. We are yet to repeat that experiments also, but my scientists, they feel copper is not playing a very crucial role in killing the Borrelia. Again, this is the first time they did, but we need to repeat to check, whether we did everything right to answer this question.
Did you test the different types of Borrelia that exist, including Guarini, Sensu stricto, Miyamotoi, or only Burgdorferi?
Only Burgdorferi, we focused only on that. If we give an opportunity funding, we will definitely look for other things, but they are likely to have a similar effect.
Okay. There's an effervescent version of disulfiram that's available in Europe. Do you happen to know if that one would be, based on what you're saying, it would be preferable to take that slowly over the course of a day, as like if you could somehow divide tablets and take them slowly over the course of the day?
By dividing compressed tablets, you are promoting slow delivery. By taking an effervescence tablet, you are promoting burst delivery we call, which is not very good for borrelial sterilization. Again, I always say whatever I say, it should not be taken as a clinical advice.
Definitely, yeah. None of this is to be construed as medical advice whatsoever. But this person was just asking if they can only access the effervescent form, I guess would it be better to potentially take it small sips throughout the day instead of taking, one big glass at a time? It sounds like that wouldn't be necessarily a bad idea, potentially. But
Uh, I don't know. I
we
don't
can't
know
give an
that.
answer
So
to that.
I need to get those effervescent vessel, tablets, and then model that response, by giving it to animal. Then I do the HPLC and mass spec analysis of disulfiram level in the blood. Then I come back and then say this is how it works. Without those experiments, it's very, very difficult to. But it appears it's, maybe it's a good idea. We don't know.
One person asked if there's any difference between genders with disulfiram, male or female.
Yeah, that's a very interesting question. Recently, somebody, one of my collaborator, she sent an article of how the dopamine level changes, how the epinephrine level changes in both, with respect to the disulfiram, and how this particular change in level of dopamine and epinephrine is likely to vary between male and female. The answer is yes. We just found out some very good previous work in this area, and I immediately gave all the papers to my team, Dr. Ravindra Pothineni and Dr. Ayafuddin Ahmed. Both of them are fascinated by this particular variation, gender variation. So they are started working on it.
Interesting. So that's really just an effect in the brain, but not in terms of the efficacy of the drug in killing Borrelia. No.
Yeah, no, I don't think so. But um, yeah,
You tested mice that were male and female, I assume.
yeah, that's correct. Yes.
Um, do you have any opinion on taking other antibiotics in conjunction with disulfiram?
So far our approach is always go with one antibiotic. We never recommend a combination. So far, actually, because we don't know ultimately we will be pushed into 2 or 3 antibiotic to clear everything. So far, we wanted to focus only one antibiotic approach.
One question, someone said that you had a recent presentation that discussed minocycline. Is that true?
Oh, it's not a minocycline. So when we started, we found out a loratadine is having some kind of symptom reduction in percentage of patients. So then we realize it is sterilizing ability of Borrelia is very, very limited, even though it reduces the symptoms by maybe acting as an anti-inflammatory molecule. We don't know exactly how it acted. So what we did is to reduce the borrelial sterilizing, we used a minocycline in that we proposed to use minocycline along with loratadine. Nowadays, we are not promoting minocycline for this because we think one of these molecule we are developing now, they can totally reduce the borrelial content in people, both in acute and chronic condition.
So you have no recommendation that minocycline or any other antibiotic needs to be used in conjunction with disulfiram, right?
No, so far, no. I would rather prefer to have a monotherapy, and later maybe for other co-infection if people wanted to try maybe some other antibiotics.
One person asked, I'm not sure if you have any insight into this, whether or not taking Biaxin and rifabutin with DSF would reduce disulfiram's effectiveness?
I don't know the
Okay.
answer for that. For that, I need to do experiments. But I will keep this in mind. Please send the questions, if possible. The questions I didn't answer it.
Okay. Do you know what the longest amount of time a patient has been symptom free after taking disulfiram has been?
I think this question the clinician need to answer. So
Okay.
I will ask Dr. Kenneth Lehner and other clinicians who have a longer experience in using disulfiram for patients. I will ask them to answer for that. Maybe they have an answer for that.
Okay. By the way, your camera sometimes shows only half of your face, so if you could move it a little bit, yeah, that's
Okay.
perfect. Um, I was just wondering, there's been a few people in the Facebook group that have started taking the enteric coated form of disulfiram, and I was just wondering, do you have any thoughts on whether or not that might be able to get all the way to the large intestine?
Uh, all the way large intestine is kind of quite ambitious with entry coating, but entry coating definitely likely to reduce liver exposure.
Okay, interesting. Is some people have even taken it to the extent of doing a double enteric coating. Do you think that makes any sense at all? So putting a
So
capsule within a capsule.
yeah, that's it's a both positive and negative sides in doing that. The positive things definitely it will delay the exposure of disulfiram in the upper intestine and stomach. But at the same time, let us say if the double entry coating never opens up, like without any drug absorption, it leaves the body, then that is a possibility. So uh, I don't know basically the answer whether that approach is going to work. Like you need to do how many layers you need to put. That is the question. We need to do experiments and then see whether that is possible. That means human experiments like you take 10 patients, so not 10 patients, 10 volunteers, give them one coating and then you give two coatings and then you periodically take their blood and then see disulfiram level. That is the question experiments we need to do as soon as possible.
Do you think it's better to take the capsules without food on an empty stomach?
People say when they take oily food, absorption is much better.
But I see there's kind of like a little bit of a pro and a con. If you take it with food, you might reduce the pH, which is good, but it also means that you're likely going to break down the capsule in the stomach, right? And the contents will burst in the stomach if you take it with food because the stomach digestion
Yeah,
is 2 to 3 hours long of fatty meals, potentially.
that's correct. That's correct. You are perfectly correct. Yes. And again, yeah, you are correct.
So the question is it better to avoid acid and to, or is it better to avoid, um, yeah, so if you, sorry, I'm not thinking clearly. The Lyme disease is getting me a little bit, is
Yeah.
getting my thought process a little bit here. But if you take it on an empty stomach, you're able to get into the large intestine quicker. But if you take it on a full stomach, you have a lower, a more alkaline pH. Um,
Yeah.
so which,
I mean, I prefer it's it's better to push them to the large intestine as soon as possible. But
I lost your
again,
video here, Dr. Rajadas. I don't know if, did you turn it off by mistake?
no, I didn't because it's a battery is low. It is just automatically turn it down. I have to uh, attach it to the battery. Sorry, the charger. If you give me some time, I will do it. So how long this is going to go?
We
This
can pause whenever you'd like, and we could resume another day. Um,
Yeah, maybe we will resume another day because I have a next meeting. Somebody is waiting.
okay,
5:30. I need to be there in the campus.
okay, but just
Uh, so
I guess to just to wrap up this topic here, it sounds like you're saying you're not really sure if it's better to take on an empty stomach or without or you are saying it's preferable to take on it on with food. Is that what you're saying?
I'm not sure about it. As I mentioned, I need to discuss with the pharmacology team
Okay.
and also do one or two experiments, and then only I can tell something, because I don't want, clinic. Obviously, this is going to be watched by clinicians. I don't want by just watching something without experiments, I recommend something and then people take some decision on that. I really don't want. In fact, no clinical decision should be taken by my suggestion. It's just a knowledge. I'm just sharing my thoughts and knowledge of my experience with Disulfiram.
Right. Okay, yeah, I think there's just a little bit of conflicting information because most enteric capsules are taken on an empty stomach because they want to avoid staying in the stomach for long. They want to get out of the stomach
The,
fast. But then a lot of people in the community are saying to take this after a meal because the pH of the stomach is more alkaline, which is better.
I mean, with whatever the understanding I have right now, again, it's not a final. It should not be taken a clinical advice. It's better not, taking along with the food. And then because then you are pushing it to the lower gut as soon as possible. That's what I think.
Better taking it not with food. Better taking it after food or on an empty stomach.
Uh, Better, kind of empty stomach. After that, they can take food. Yes.
Okay. All right, well, we'll wrap up this first video and we'll resume. We've got quite a few more questions from the community, so maybe we'll do two or three different interviews if that's okay with you.
Yes, yes, yes. And also, some of the questions I didn't answer. Maybe you can just take those questions and then send it to me. I will discuss with my team and also some of the pharmacists, and I will tell what is the best way to do this. And also, again, make sure that nobody takes any clinical advice from this interview.
Yeah, absolutely. I guess I'll close with that um, for sure. Definitely, nobody should construe anything that we talked about as something that could replace medical advice from your doctor. Definitely seek out medical advice about any of these decisions because we could easily be guiding you in the wrong direction. So, anyway, I think that's pretty much all for now. I want to thank you very much, Dr. Rajadas, for your time. And I want to thank the community for all the questions. Thank you to Beverly and Joseph and Fiona, who all helped me for many hours to work on the questions. And we have a lot more to go through. And if you have any questions that you feel we might not have answered or not included in this list, definitely reach out to me. All right. Is there anything else you want to add before we close?
No, again, I wanted to thank all of enthusiastic people about this amazing therapy. Thank you very much for the support. Thank you very much for your patience. Thank you.
Yeah, and thank you, Dr. Rajadas, for everything that you're doing for the Lyme community. And we hope that the Lyme community will continue to show you much more support than they have going forward. And
Yeah, thanks a lot.
all right, thank you, Dr. Rajadas. Bye for now.